Hi class, this is course 2 lesson 75. We're going to do two things today. It's area of a complex figure and area of a trapezoid. So here is a complex figure. Complex figure just means that it's made up of more than one figure. So for instance, I could draw a dotted line right here and divide this into two shapes, right? I can make a rectangle and a triangle. So we're going to calculate the area, and our dimensions are in millimeters. So basically what I made here is a rectangle with dimensions 10 by 7 and a triangle that used to be 16 down here, right? This whole base was 16, but if this is 7, then this side is 9. And over here, we need to find this height. The height of the entire rectangle is 10, but I know 4 of it is here, so this piece would be 6. And there's a right angle there because I drew perpendicular down, so I'm going to find the area of the two shapes. Area of a rectangle is length times width, so I substitute my 10 times 7 and I get 70. Area of a triangle is 1/2 base times height. So this is going to be 1/2 of 9 times 6. And now here I can simplify 1/2 of 6. I can do that right now. 3. So when I multiply, I get 27. Now I have an area of a rectangle and the area of a triangle that will combine to make my entire shape. So I need to add them together. So 70 plus 27 is going to be 97. I need to label it appropriately. It's millimeters and it's area, so it's squared. Okay, here's another figure. The dimensions are in centimeters. Now, I'm going to illustrate a number of ways that we could divide this. We could divide this here and make a rectangle, and we could divide it here and make a triangle and then another rectangle. Okay, so let's do that way. So we have a bigger rectangle, we have a triangle, and we have a long skinny rectangle. So this side is 10, right? But it's no longer 10 here because I cut that off. So this is 3. So if this whole side used to be 10 and this is 3, then what is this? That's 7. And we know the width is 6. Okay? So then the height of our triangle is the same as the height of our larger rectangle, so it's 7. But we need to find this length here. And if this side is 6 and this whole side of the rectangle at the bottom is 10, then this must be 4. And this rectangle is 10 by 3. That one's probably the easiest one to do. So now we start calculating. This is length times width, so it's 6 times 7, or 7 times 6, which would be 42. This is 1/2 your base times your height, so it's 1/2 4 times 7. You can put those in any order you want. So 1/2 of 4 would be 2 times 7, which is 14. So I have 42 and 14. And then over here I would have 10 times 3, which is 30. And again, I need to add them all up. So I have 42 plus 14 plus 30, which is going to be 40, 50, 60, 70, 86 centimeters squared. Okay, now, one other way that you can do this, and I will work in blue, is that you could find the area of the whole thing. So you could find the area of a 10 by 10 square, which would be 100, and then we'd have to figure out what the dimensions are of this piece to find the area that we take away. Okay, the area of the full square minus the corner we cut off. So this corner, this dimension here would be 4, and this would be 7 to make our 10 by 10 sides. So we'd find the area of that triangle. So the triangle area would be 1/2 times 4 times 7. So half of 4 is 2 times 7 is 14. So if we do 100 minus 14, we should get 86. 86 centimeters squared. So that's another way that you could do this problem. Now, this is a trapezoid. The previous two scenarios were not trapezoids. Trapezoids have parallel bases. Okay, so we have two parallel sides. And we have a height that is perpendicular to the bases. And how can you tell that you have a perpendicular segment to bases? You're looking for that right angle. Okay, so here's the formula you must memorize. It is the area equals 1/2 times the sum of your bases times the height. Or you can think of this as averaging the bases. This piece right here is the average of the bases. You add the bases up and divide by 2. Okay, so let's do an example. Area equals 1/2. We're going to add the bases up and then multiply by the height. So we're looking for the two parallel bases. We have 10 plus 7 times our height that is perpendicular to our bases, and now we simplify. Area equals 1/2 of 17 times 6. Now, here's where, notice that this is multiplication, right? We have 3 factors here, so we can rearrange. We can do 1/2 times 6. Commutative property says I can reorder these so that I can see that that would just be 3 times 17, and 17 times 3 is 51. So the area of this trapezoid is 51, and it didn't tell me what the units were, so it would just be units squared. Area is still square units. Okay, that's all there is for lesson 75. One formula to memorize and different scenarios that will help you solve for area of a complex figure. And with that, I will see you in class.